those blooms. Then also with freshwater, we have marshes and swamps. These are freshwater wetlands usually covered by shallow water for at least one part of the year. Very high, rich organic matter. Anaerobic conditions. So what does that mean, anaerobic? Yeah, no oxygen, right? No oxygen conditions. And this also helps purify groundwater by absorbing a lot of pollutants and different bad stuff within water. You have marshes, which here, you see marshes, which have grass-like plants that dominate, and then swamps, which have woody shrub-like dominance. So you've got a swamp here and a marsh here. Very productive ecosystems. Very essential ecosystems. And then estuaries. Estuaries are coastal bodies of water partly surrounded by land with access to open ocean and large supply of fresh water from a river. These are among the most fertile ecosystems in the world. They tend to trap pollution. They allow storm buffering, so help prevent storm erosion further in. Large biological habitat, and contributes to groundwater supply. Salt marshes are temperate estuaries, shallow wetlands dominated by grasses, once again, and mangrove forests are the tropical equivalent to salt marshes, and they cover about 70% of tropical coastlines. The Chesapeake Bay estuary, which is, you can see here I've got the United States, we're looking at Pennsylvania, New York, West Virginia. The mouth is here in Maryland and Virginia. And this is the most productive estuary in the United States. 9 rivers and about 150 headwater streams empty into this estuary. New oyster reefs and habitats are being successfully created and colonized within the bay. But there's been a huge problem in this estuary with agricultural runoff and eutrophication. And you can see here with nitrogen loads. Now nitrogen and phosphorus tend to be these limiting resources in these ecosystems for plant growth. So the more you have them, the more plant and phytoplankton blooms you get. And you can see we get different concentrations of chemical fertilizers and different areas where this nitrogen is being run off into this estuary. Agriculture making up 16%, manure from agriculture, atmospheric nitrogen through fixation, about 33%, septic, all right? So you have your septic outside your house or your apartment complex, and that can leak into, it filters through the ground, and that eventually, that nitrogen and phosphorus that you unload gets filtered through the system. Municipality wastes, which are like wastewater treatment plants, and then also urban and suburban areas from chemical fertilizers, from trying to fertilize your plant growth in your outside your house. Marine ecosystems, last but not least. The immense marine environment is divided into several different areas, kind of like your lakes are. You have your inner tidal zone, which deals with your tides, which is here, your benthic, which is down below, and your pelagic, which is here, also known as the euphotic zone, which is your open area that gets a decent amount of sunlight. Looking at the intertidal zone, these are areas of shoreline between low and high tides. High levels of nutrients, light and oxygen tend to be in this area. High biological productivity, and a stressful zone. Imagine if your place that you lived had a flooding period 2 times a day, every day. Well, that's what these organisms have to deal with, this high and low tide, which floods the area. So it can be a stressful area, or different types of waves that are coming in, crashing into them. Some common organisms, we've got barnacles, sea stars, mussels, isopods, hermit crabs, different types of crabs, sea anemones. So yeah, those are some different organisms with the intertidal zone, dealing with the tides. Benthic zone. Benthic zone, ocean floor. All right, so we've got our benthic zone, which is down below. Very low to no light penetration. The abyssal zone of the abyssal benthic zone, which we've got here, extends from 4,000 or 4 kilometers, 4,000 meters, 4 kilometers to 6 kilometers, 6,000 kilometers, or 6 kilometers, I'm sorry, down. And then you have the Hadal benthic zone, which is all the way at the bottom. Some organisms that you would find in those areas. No light. And then coral reefs, which are the most diverse of all marine ecosystems. 1 out of every 4 marine organisms live on a coral reef, found in shallow, nutrient-poor tropical waters. Isn't that funny that this nutrient-poor area, like tropical rainforests and coral reefs, have this nutrient-poor area, though they have this such diverse area. Coral reefs tend to protect the coastline from erosion, right? Tend to slow down water as it's moving inward. And it also occurs as a barrier fringing atoll formations. You can see here with the food web of our coral reef. Got our producers in green, you can see here with phytoplankton, algae, and then secondary consumers with our brittle stars, zooplankton, and then secondary, right, red, and then all consumers, to decomposers, are in orange. Some human impacts on the marine systems. We have coastal development, one of the most demanded areas of land. Everybody wants to live on the coast, which most people do, both residential and industrial. Global warming, increased CO2, we can have an increase of ocean acidification, like you saw with the video with Sigourney Weaver. All right, more carbon dioxide absorbing in causes an increase of acidity in the ocean, causing those primary consumers or primary producers to not be able to build shells, therefore not allowing them to compete ecologically against everything else. Also, trash buildup. I've got a jelly star here, or a jellyfish here, that's got a net caught around it. And there is a lot of trash just floating around in the ocean. And then also chemical pollution from runoff of pesticides, heavy metals, and synthetic chemicals. Here I got a picture of the dead zone. You read with the agricultural runoff and how hypoxia, which is the decrease of oxygen, causes a area that nothing can grow, and that's all because of the Mississippi filters in right here. All that agricultural waste, as it runs off into the Mississippi, all that phosphorus and nitrogen ends up here in the Gulf of Mexico. All right. So there we go, chapter 7.